The Singleton pattern is a creational design pattern that ensures that a class only has one instance and provides a global point of access to that instance. The single instance is commonly used for managing shared resources, configuration settings, or logging functionality within an application. A common use case of the Singleton pattern is to use a single global instance of a database object throughout an application. This means that all clients that need to connect to a database will retrieve the same database object and will not be creating new separate database objects. The database object is only created once, the first time it is needed, and then all of the clients that need to connect and query the database will use this same database object. So here's a user making a request to fetch some products. There are two classes, user authentication and products. Both require fetching things from the same database. Notice that we are not using the new keyword to get the database object. We are using a method called getInstance that returns the exact same database object throughout the application, ensuring that we always use a single database instance. So you can see here we have our user, which goes through two classes. So first of all, we authenticate the user, and to get the database object, we are calling db.getInstance. We are not calling db equals new database, whatever. Okay, so we're not using the new keyword. We're using this sort of factory to get the same instance of the database object. So it's going to be cached somewhere in memory. So you may be wondering why we can't just create a new database object every time we need to connect to a database. So here are some good reasons to use a single global database object in all clients. So you can see here we have two clients. The authenticate user class is a client of the database object, and this products class is also a client. Okay, so here are some good reasons to use a single global database object. So first of all, for resource efficiency. So database connections and resources are typically limited and can be expensive to establish. So by using a single instance of a database object, you minimize the overhead of creating and managing multiple connections, optimizing resource utilization. Also, consistency and state management. So having a single database instance ensures consistent state management and transaction handling across different parts of the application. Changes made to the database state are visible universally within the application, avoiding inconsistencies that could arise from multiple database instances. So we also simplify configuration and management. So with a Singleton database instance, configuration settings such as connection parameters, credentials, and initialization logic are centralized and managed in one place, and this simplifies application setup and maintenance. We also have performance optimization. By reusing a single database instance, you can optimize database query performance and reduce latency associated with establishing new connections or reinitializing database resources. So the Singleton pattern is great for storing app configuration settings. It's also great, I should say, for storing app configuration settings, logging configuration, session information, authentication tokens, and making this information available globally via a single instance, ensuring that it is the same throughout the app. So you can see there are many reasons why we would want to keep a single instance of an object throughout the application rather than creating new versions of that object in multiple clients. And we can see here some more specific reasons why we would want a single database instance. So say that we need to keep an app settings object that stores global variables such as the name of the application, the database configuration, for example, what database type we're using, whether it's Postgres, SQL, MongoDB, the username and the password. And also logger settings such as the file location for our log file, the format, whether it's text versus JSON, etc. And we need to create only a single instance of this object throughout our application to ensure that it only needs to be configured once in one place and to ensure consistency throughout the application. So first of all, we're going to create a poor solution to this problem. So first of all, let's create a new folder for our Singleton Pattern example, and that is a creational design pattern. So let's create it in there, and this is called Singleton. Okay, so first of all, let's create our app settings object, or class I should say. So app settings, and in here we're going to create a dictionary field, and each dictionary, the dictionary is going to have keys which are strings, and the values are going to be objects. Okay, and this is where we're going to store our settings. Okay, and each setting is going to have some key, such as app name, and then some object, and the app name could be design patterns mastery, for example. Okay, so first of all, we need to create a method called get for getting values from our settings object. So here we first need to check if the setting with this key name actually exists in our settings dictionary. So here we can say if the settings and contains key. So if the settings does not contain the key provided, then we're just going to return null. Otherwise, we can return the settings object corresponding to the provided key. Okay, so next up we can create a sept method, and this is for setting settings values. So we provide a key and an object value, and here we can simply call settings key equals value. Okay, so we set a settings value with this key and this value. So next up, let's have a look at how we can use this solution in a client. So what we can do is first of all create a settings object. So we'll create new app settings equals new app settings, and then let's actually set a few settings. So we can call settings.set, and then we'll say app name is design patterns mastery, and let's also set another setting for app creator, and I'm just going to put my name, so Danny. Okay, so then let's actually console log one of the settings just to check that it's working correctly. So we can say settings.get, and let's get the app name. Okay, so this should be design patterns mastery, so let's run this. And we can see that it's been set correctly, and we are retrieving it from the settings object without any problems. So next up, let's actually test getting a setting from a different client. So this is here a client, a class that is using this app settings object. So let's now create a test class, and in here I'm just going to create a method called run, so run the test. And let's see, so first of all we need to get our settings object. So let's get our settings object here, and then what I want to do is retrieve this app name. Okay, so as you can see in program.cs we are setting the app name, and then we get the app name here, and then in a different class, in a different client, a client is some class that's using this app settings object or class, and we are trying to get the app name which was set in program.cs. So now let's actually run this test. So maybe if we make this static, we can just access it directly just for convenience, and let's run this program, and we can see we get null. So null is returned here because in test the app name does not exist. Okay, so you can see here that we need to use the Singleton pattern to ensure a single instance of app settings is maintained throughout our application, because here we can see we are creating a completely new app settings object. And this is kind of fine if this is the first time we're doing it, but then we're also creating another app settings object, a separate, different settings object, and then we're trying to access app name on a different object to what we created in here. So we're going to need to use the Singleton pattern to solve this issue, because every time we need to use the app settings object, currently we are using the new keyword, and so creating a new object. So the solution is to use the Singleton pattern. So to ensure that we have only a single instance of this app settings class, we first have to make the constructor private. So notice in this UML diagram that the constructor, so this app settings constructor, has a negative symbol in front of it, meaning that it's private. And this means that we won't be able to use the new operation or the new keyword with this app settings class. And also notice that we have a private static. So static is being symbolized by this underline here in the UML. So notice that we have a private static instance field that holds an instance of the app settings class. In other words, this class is responsible for maintaining a single instance of itself. And we also have a getInstance method, and this again is a static method for getting that single instance. And the reason that this method is static is because that static fields, so this static field here, for example, and static fields are only visible to static methods. So if this wasn't static, it wouldn't be able to access this instance field, because static fields belong to the class itself rather than the objects that are instantiated from it. So let's have a look at the gang of 4 representation here. We see it's very similar to what we have up here. We have a class called Singleton with an instance, a static private instance of itself. We have a private constructor so that the new keyword cannot be used outside of the class itself. And then we have a getInstance method, which basically returns the instance of itself. So to implement the Singleton pattern, you have to do a few things. So first of all, we need to make the constructor private so that the new keyword can't be used to create multiple instances of this class. Okay, so we can only create an instance of the class inside of the class itself. So another point is that we have to create a private static instance field to keep reference to the single instance that is created inside of the class. And we have to create a public static getInstance method for creating that single instance the first time the method is called in the application, then returning that very same instance every time the method is called. So let's now implement this solution in code. So let's now refactor our app settings class to adhere to the Singleton pattern. So first of all, we need to create a private static field for holding a reference to the instance. So let's create that. So private static app settings. So this is going to be an instance of itself. We're going to call this instance, and we're going to leave it as null initially. So next up, we need to make the constructor private. This is a very important step in the Singleton pattern to ensure that instances of app settings cannot be created outside of the class itself. So this means that the class itself will be able to create and maintain a single instance of itself throughout the application globally. So let's make the constructor private. So private constructor, and it's just an empty body. So next up, we need to create a method for creating a single instance of this class. We're going to call this method getInstance. So this is going to be a static method called app settings, and we're going to call it getInstance. And what we're going to do here is we need to check if the instance is null, and if the instance is null, so the first time that this method is called, the instance is going to be null, so we need to create a new instance. Okay? Otherwise, we just return the instance. So the second time that this getInstance method is called, instance will be set to an appSettings object, and therefore this will not run, and we will just return that very same instance as we returned previously. Okay, so I believe everything else should be the same as before. So we have our get method for getting certain settings via their key, and we have our set method for setting different settings. So I believe that's everything that we need to do. So now what we can do is we can go into our program.cs file, and I'm just going to change the namespace to this new solution. And let's see, what is the error we get here? So app settings is inaccessible. Okay, so now we can see that because we were previously using the new keyword to create an app settings object, it's now giving us an error because appsettings.appsettings, so this is the constructor, is inaccessible due to its protection level. So if we look in app settings, the constructor is now not accessible outside of the class, so we're going to get an error. So now to create the settings object, we need to call appSettings dot getInstance, and this now returns an instance of the settings object. And we can use the settings object just as we did before. So we set some values here, and then we log the app name at the bottom. So let's test that this works correctly as it did before, and we can see that we get design patterns mastery just as we should. Okay, so that's perfect. So now let's actually test out getting this instance in a different client somewhere else in our application. So if we go into our new example folder and create a test class, and in here I'm going to create a public static method called run. And what we're going to do is we're going to again get our settings instance, and I'm going to try to retrieve the app name. So let's actually see if this works. So now if we run test.run, we should get design patterns mastery, because here we get the instance from settings, from our app settings, and this creates a new instance and caches or stores this instance in the instance variable on the class. So you can see that this is a static field, meaning that it's stored on the class itself and not within new objects created elsewhere in the program. So let's see if this works. And as you can see, we get design patterns mastery logged twice. So this is perfect. We now have a global instance object for our settings.